first question whenever you're factoring, no matter what, is that you ask, is the leading coefficient negative? Is the leading coefficient negative? Ladies and gentlemen, we tend to forget about this. And it's the first thing we should look for. And the reason we forget about this is because you start doing problems and like 5 problems in a row all have a positive leading coefficient. And so you start to forget to check for it. And then all of a sudden, along comes a leading coefficient that's negative.
And you do nothing.
And you forget about it, and then your answer is wrong. Is the leading coefficient negative? If it is negative, factor out the negative, change everything else in the problem, right? Positives become negatives, negatives become positives. Then I ask, is there a GCF? Because if there's a GCF, you should get rid of that GCF also. Because a GCF, all it does is make numbers bigger. And when we're factoring, I prefer to find factors of smaller numbers instead of larger numbers. I would rather find the factor of 49 than the factor of 373.
And then we all would.
Right? Hopefully. The first two things, no matter what the polynomial looks like, you should always look for a negative coefficient and then a GCF. And then once you've done those two things, we can start factoring based on the special types of rules we've discussed. And the special types of rules deal with how many terms. Because we have rules for how many terms there are. So once you've found a leading coefficient, if it's negative, take that leading coefficient out, right? Once you've done that, or maybe there isn't a leading coefficient that's negative, and you just move on. Once we look and we determine, is there a greatest common factor, and if there is a greatest common factor, we remove that greatest common factor. If there's not a greatest common factor, we move on. Once we've gone through those two steps, now we have to use our special rules, our rules that are specific to types. We only know how to factor 3 types of polynomials. We can factor a 2-term polynomial. What's a 2-term polynomial called? A binomial. We can factor binomials. 2 terms is called a binomial. We can factor a binomial, no S. And in fact, binomials over and above are probably the easiest to factor because there's only 2 choices. Now again, every single factor or polynomial, no matter what it looks like, we do these 2 steps first. Leading coefficient that's negative, get that out of there. If there's not, then we move on. Is there a GCF? If there is, get it out of there. If there's not, move on. Then we come to our terms. I know that if it's a 2-term binomial, I only have 2 choices. If it is a 2-term binomial, I only have 2 choices. It could be a difference of squares, which we talked a little bit about yesterday. 2-term binomials. It could be a difference of squares. 2 terms, binomial. One option is it's a difference of squares. And that was our discussion yesterday. A difference of squares. What does difference mean? It has to be a subtraction problem. If it's addition, no more, like we're done. And it must be a difference of squares. So it must be a perfect square minus a perfect square.
What?
If it's a perfect square minus a perfect square, we can factor it further.
Perfect square.
We talked about this yesterday. If it's a difference of squares, so it has to be a subtraction problem, and both of them have to be perfect squares, then we can continue to factor it. So that's one way of factoring a binomial. If it's a binomial, and again, remember, we did the leading coefficient is negative. We did that first. Then we look to see if there's a GCF. We did that second. And then we've got this problem now, and we say either yes, it's a difference of squares, and we do that, or we're done. For a binomial, there are only two choices. It's either a difference of squares or we're done. No more factoring can be done to that problem. So this is how you factor a binomial, a two-term. What's a three-term called? So we can factor trinomials. We can factor trinomials. For a trinomial, it could be easy. Or it could be hard. What form does an easy trinomial take? What does an easy trinomial look like? What's the formula for an easy trinomial? Say again.
X squared plus bx plus c.
X squared plus bx plus c. You are correct. An easy trinomial is x squared plus bx plus c. There is no leading coefficient. I mean, there is. It's 1, so we don't write it. Easy trinomials are in the form x squared plus bx plus c, or another variable, right? To factor an easy trinomial, we call it unfoil, correct?
Yes.
We unfoil it. How do you unfoil it? What's the rule? What's the saying to unfoil or to factor an easy trinomial? What are we looking for when we are factoring an easy trinomial? What are we trying to find?
First, outside, inside, last.
That's how you foil. How do we unfoil?
First, outside, inside, last.
Was that the Xbox one? Or was
That's the hard one.
that... Oh, my bad.
How do you find your factors?
Oh, you what's it called? You unfoil it.
Factors of
Factors of blank have a sum of blank.
factors of C
Yes.
Have some views.
that have a sum of B. Factors of C that have a sum of B. If it is an easy problem, it's in the form x squared plus bx plus c. We look for factors of C that have a sum of B. Factors of C that have a sum of B. If it's factors of 15 that have a sum of 8, then we can factor it. What do hard trinomials look like?
They look like
X box.
squared
Claire?
plus
AX squared plus BX plus C.
Perfect. Ax squared plus bx plus c. The difference between an easy and a hard is that the easy does not have a leading coefficient, and the hard does have a leading coefficient. To factor a hard trinomial,
X box.
we ungrid it.
Oh.
Xbox is a method, right? Xbox is a method of factoring. Xbox is an organizational tool. We ungrid. How do you fill out the information? How do you get the numbers that you need? What do you look for in a hard problem? How do you fill in the Xbox? Factors of
AX squared and C.
factors of A times C, or AX squared times C. that have a sum of b. Easy problems. X squared plus bx plus c. Factors of c that have a sum of b. Hard problems. We ungrid it. Factors of a times c that have a sum of b. And Xbox is our method of figuring that out, but we look for factors of a times c that have a sum of b. Or, if they don't fit either of those, you're done. We can factor 2 terms, which is a binomial. We can factor 3 terms, which is a trinomial. Or we can factor
Polynomial.
4 terms, which is a polynomial. And we learned about this yesterday. If it is a 4-term polynomial, we factor by grouping. That's what it's called. What are the steps to factoring by grouping? If it's a 4-term polynomial, what do? After we look for a leading coefficient that's negative, after we look to see is there a greatest common factor, what do we do to our 4-term polynomial? What did we learn yesterday, Trinity? Split it in half. Oops, that's not it. That says splint. Split in half. Say again, then what do?
You find a common factor for the two.
Find the GCF for each half, right?
Yes.
Then what do?
You put together. Well, you do it together. Once you've done it to both sides, you take the greatest common factors and put them into a parenthesis side.
So it's GCF and GCF,
Yes.
and then
It's the leftovers.
leftovers.
Makes me want to have mashed potatoes.
What happens if your leftovers don't match?
Then you did it wrong.
You might have done it wrong. Or, so I would check your math. That would be your first thing, right?
Yes.
Or, Jacob, what is it? Unfactorable. If it does not fit the grouping, right? If you split it in half and it just doesn't work out, you're done. If it does not fit the rule of grouping, you're done. You cannot factor anymore. So again, to do these problems, the first question is always, is the leading coefficient negative? Then we ask, is there a GCF? These two things always go first no matter what kind of polynomial it is. If it's a binomial, we have 2 choices. Either it's a difference of squares or you're done. If it's a trinomial, we have 3 choices. It's easy, it's hard, or it's done. And if it's a 4-term polynomial, we have 2 choices. It's either grouping or done.